Now, the old masters, they knew, didn't they? Shakespeare told us in Hamlet 400 years ago, there are more things in heaven and earth, Horatio, than are dreamt of in your philosophy. Now, according to our next guest, everything we've told through the generations about the universe could be turned on its head in the coming years because of a new branch of astronomy. It's based on gravitational waves. Now, Gianfranco Bertone calls it the multi-messenger astronomy. He's a professor in physical theory of astroparticles at Amsterdam University, and his new book is called Entre Deux Infinities, or in English, it's A Tale of Two Infinities. Right, so this is going to blow our minds, isn't it? Let's start with how we think about the universe in a new way. One way you do it is you talk about one of the astronauts to the moon came back and said, I think it was Charlie Duke, it tastes like gunpowder.
Correctly.
This is a way to explain how we can understand the universe.
Yeah, because, you know, that sentence that was said by astronaut Charlie Duke and many other astronauts who've been on the moon gives us the opportunity to reflect on the fact that we perceive the universe, or at least we have perceived the universe throughout the history of humanity, only through our eyes. This is maybe not very surprising. You cannot touch or taste everything that exists in the universe. On the other hand, if you think about it, that kind of limits our understanding of the universe. And what has happened throughout the history of humanity is that the first big revolution was the invention of telescopes, allow us to see very far in the universe, but still using the kind of light that we can perceive with our eyes. The second big revolution was in the 20th century, because we started to observe things, the colors of the universe that are invisible to our eyes. So energy, light, electromagnetic waves, with energy much below what we perceive as red with our eyes, so infrared, microwaves, radio waves, and so on. And electromagnetic waves with energy is much higher than violets, ultraviolet, X-rays, gamma rays, and so on.
Wow.
But then the third revolution came, which is the revolution we are living through today, which is that we're starting to perceive the universe with other senses other than light, and we use in particular cosmic rays, neutrinos, and gravitational waves.
You explain it in the book. You try and take us on like a Dantean quest, heaven and hell, looking at the two infinities, the small and the big. Tell us about that.
Sure. Well, the thing is, the discoveries of modern astronomy, they've opened our horizon on a very mysterious universe. A universe which is full of mysterious forms of matter and energy that we call dark matter and dark energy, and of places and events where the known laws of physics break down, like black holes and the Big Bang, the very origin of the universe. All of these mysteries, they seem to have something in common, because they arise from the observation of the universe on very large scales, but they seem to sink their roots in a microcosm which is ruled not by gravity, but by quantum physics, right? And the physics of subatomic particles. And that's what we're trying to do with this new astronomy, with the astronomy, the multi-messenger astronomy. We're trying to solve these mysteries and establish this connection between two infinities.
So am I right to say that previous scientists have basically added to the foundation of what's known about cosmology, but with this sense now, some of those, you know, bricks that we've built could topple over, and we need to look, I guess, at, I think the right word is gravitational waves. We've got some black, dark energy, dark matter of the black hole in the background. Explain that in layman's terms, what we should be thinking about. You touched upon it a second ago, but where that potentially could take us to look again at the universe.
Absolutely. Yeah, so let's consider gravitational waves, right? So imagine that there's an earthquake, right? You don't see what's happening below the ground, what is causing the earthquake. But if you're a geologist, you can reconstruct the position, you can reconstruct the energy that is emitted, and so on. So you have access to information that you wouldn't get from the observation with your eyes or with your telescopes or microscopes of what's happening below the ground. In the case of gravitational waves, that's exactly the same thing. The only difference is that it's not vibrations in the ground that we're talking about, but in vibrations of space-time, right? And Einstein told us that space and time are not separate entities. They're part of a continuum.
The theory of relativity.
Correct. So the theory of special relativity told us that they're the same, there's part of a continuum, that one can be transformed into the other, so to say. And then with the theory of general relativity, Einstein told us that one can bend this space-time, and that what we observe as gravity is a manifestation of this curvature of space-time. Now, the thing that Einstein already understood very early on when he formulated this theory of general relativity is that there are solutions to his equations in the form of waves. Everybody was very confused about the existence of gravitational waves. For decades, people debated whether they even existed or not. Einstein himself got very confused. He tried to prove that gravitational waves didn't exist. With the very gravitational waves that he proposed.
So Einstein was wrong.
And that, you know, is one of the cases where Einstein was wrong. And that's one of the themes of the book, is precisely to show that science goes beyond individuals. And that we manage today, you know, sometimes, you know, gravitational waves and black holes are celebrated as Einstein was right, you know, that's what we always say. But in fact, Einstein didn't believe in the existence of gravitational waves. He said that the existence of black holes was absurd, right? So what was really true is the theory he discovered, he stumbled upon early on in his career. And that theory, the theory of general relativity, turned out to be always right so far.
What's driving it? Because I mean, I talked about this. You know, we could have a different sense of the universe. How many years should we wait? And is it AI technology? What sort of technology is driving these discoveries?
Well, it's a combination of things, right? So first of all, the fact that we have gravitational waves, as we were saying, gives us a sort of a new sense to perceive the universe, to perceive what's out there. So we're going to use this to try and establish this big connection. So I'm going to give you just one example of the new things that we can do. In Einstein's theory of general relativity, we know how to solve the two-body problem. If we take two black holes that orbit around each other, we can describe the orbit, the evolution of the orbit, and the emission of gravitational waves with a fantastic precision. But suppose now that there are all these dark matter particles floating in the universe, and then in particular, that dark matter particles that cluster around these black holes. Well, this would modify the orbits of the black holes. It would modify the emission of gravitational waves. It would modify the so-called waveform, the shape of the gravitational waves that are produced. And by looking for events of this type, we could figure out something about the fundamental nature of dark matter particles.
I think you've explained it brilliantly, Gianfranco, even for a layman like me. Very briefly, I grew up in a generation with Douglas Adams' Hitchhiker's Guide to the Galaxy. I was always told the answer to human life, universe, and everything else was 42.
42, of course.
Is he right?
Probably not.
Gianfranco Bertone, thank you for joining us, and thanks for all the fish. Well, that's our guest today. And the book is out. It's called Entre Deux Infinis. That's a tale of two infinities.